Our project was about the three-dimensional mapping of any environment for dimension calculation of that environment and for game development. For this purpose, we have to scan the environment. For this scanning, we used Lidar sensor which will return distance of object in front of it from its sensor node. There are two stepper motors used for the movement of Lidar sensor in order to collect the points from the room. These two motors along with the LiDAR sensor are attached on the aluminum structure made by CNC machine as shown in the video. This structure is described as the mechanical part of our project. Let's have a look at this aluminum structure. Below is the bed on which one stepper motor is attached for horizontal movement of the LiDAR sensor. This motor moves an L-shaped part above this bed horizontally through the gears as shown in the video. From the center of this L-shaped structure, wires of slip ring are coming outwards, which are for upper stepper motor with which LiDAR sensor is attached. We used this slip ring for continuous rotation horizontally in order to avoid wires twisting. After about 5.5 complete rotation of small gear coupled with the big gear attached with the lower motor, there will be one complete rotation of big gear, which will result in complete 360-degree rotation of the LiDAR sensor across the room. Hence, after this one rotation of the big gear, there will be increment for certain step in upper stepper motor and LiDAR sensor will move one step vertically. So in this way, there will be complete 3D scanning of the room. Now coming to the electrical or circuitry part of our project. There is a circuit board on which microcontroller ESP32, one logic converter, circuits of voltage regulators and SD card module is soldered. Purpose of this logic converter is to have two different levels for voltages in order to have 5 and 3.3 volts for some components which we will discuss in a while. SD card module is used to collect the data from the LiDAR sensor and motors in the form of distance and position of the motors. This thing is done to avoid serial communication in order to make system portable. On right side of the circuit board, there are two microstepper drivers interfaced with the microcontroller through which both motors are connected. We used these microcontrollers to achieve microstepping as it was the fundamental requirement for our project. On the left side of the circuit board, there is LCD module along the I2C module whose only purpose is to display the statuses during scanning and to show the possible errors if any occurs, like SD card is not properly inserted or in the wrong format, and statuses like the scanning started and scanning completed. I2C module is used along with this LCD to reduce the number of wires coming from this LCD because of limited pins of ESP32 microcontroller. Lastly, concluding the hardware part, the last component on this wooden board is solar charge controller, which is used to power the project by charging the battery of 18 ampere and 12 volts via solar panel.
Now, after giving you idea what we have made in hardware perspective, we will like to give you a detailed elaboration of software and the game we have developed using the software. The hardware gives us our data inside an SD card, and as I mentioned before, we can make it portable by using this thing. We import that file and you can see that we have imported that file from that micro SD card to our computer system. The software we design has basically three features. The first one feature is to visualize the 3D file. The second is to measure the dimensions, and third feature that we can convert this file into a binary PLY so that in future we can make games and even 3D print the file. In order to visualize the file, first we need to copy that file from the hardware SD card. We can copy that file into our installed directory and you can see the name here. After copying that file, we just click the rename button, copy the name of the file and paste it into the software we just made. By clicking load file, the system will load the file into the memory. And in order to visualize that, we can click the load test button. Here you can see we have visualization of South's hostel room. You can see the ceiling, the fan, the cabinets and every other thing in a 3D perspective. Here is the aerial view of his hostel's room. The second feature we have in our software is that we can use that map in order to find the dimensions of the walls or everything inside the map, for which we just place the cursor. You can see the button here. By just clicking it, I imported the map, and in order to place cursor, I can select the cursor button, and you can see that when I place the cursor, it will show me X, Y and Z axis on the map. In order to import these points into our system, I will just click the import select value 1. I can place the second cursor and import the selected value 2 and compute the distance. The very first thing we show here is the distance between the 2 points in centimeter. The second is in the inches, and the third one is the fourth. This will show that the first cursor and the second cursor have a distance of 1.655 between them. The third and the last feature we have inside our software is that we can convert our map into a binary PLY file, so that we can re-import this file into a gaming environment such as Unity, or we can even 3D print using the Microsoft services. On the right you can see the file we imported from our hardware, and on the left that we just converted using the software we designed. Here I open South Hostel room in Microsoft 3D printing environment, where you can see we have the same room and even we can 3D print it. Now coming toward the last feature of our project, I would like to show how easy it is to develop a game using that file. Here is the file, and I import it into my Unity environment. You can see here Unity is loading the file. It will take some time. Here the file is imported, and we can place our environment into Unity. You can see here we have same environment in our Unity. I can show you different perspective. You can see the same map we have just imported into our gaming environment. Now I would like to show a full compiled game. This is our game. The main objective is to collect the all, and you will shift it toward the next level. Here this is the same room we just scanned in our hardware, and you can see I am entering from the room's door. On the above ceiling you can see the fan, the cabinets. In this mission we have the same objective just like before. We have to catch the ball and shift it toward the next mission. In the next mission we have a brighter perspective of the room. You can see here, as I took toward the room, the frame will drop. This is because the size of the file. The developer can further reduce the size of the file according to its need. You can see the room clear here. We try to give maximum through this video presentation. Hope you will like it, but it will never take place of what we are able to deliver on the floor in front of you. But because of the virus breakout, we are unable to show you what we have. Thank you for your time.